Yeah, good morning, everyone. I have shared my screen. You please type in the chat box whether my screen is visible or not. Yeah. So, in today's session, we will try to understand briefly what exactly is machine learning, and in that, what sort of machine learning algorithms we need to learn so that we will work on our project, right? So, yesterday I've shared you one presentation. Did you go through that presentation? Yeah, I think I have also enabled mic for you people also. So you can please be on mute, and whenever you have any doubt, you can unmute yourself and you can ask. Okay. So I'll just quickly go through the presentation, and I just want to brief you about machine learning. Then we will try to understand what specific type of algorithms we need to learn to proceed further. Okay. And I'm recording this video lecture. I'll be sharing this again so that it may be useful for you in future. Okay. Right, friends. So what is machine learning? This PPT was shared yesterday with you so that before coming to the class, you will come with little bit of preparation, right? So we will briefly try to understand. So yesterday you might have observed this problems are of two types: deterministic problems and non-deterministic problems. So problems for which there exists a fixed algorithm, fixed procedure to solve a problem, all those problems come under the category of deterministic problems. So till now, whatever programming you have done in your 3 years of engineering, like C, C++, Java, Python, in all those programs, all those programming languages, you were solving only deterministic problems. Deterministic means, for example, if you take factorial of a number, so what is the logic for factorial of a number? For example, if the number is 5, the logic is 5 into 4 into 3 into 2 into 1. So the logic is n into n minus 1 factorial. So this formula or this logic or the procedure to find factorial of a number will remain same for any number. So the logic for 5 and the logic for factorial of 10 will not be different, right? So whatever may be the number, the logic remains the same. Means if you write one time the logic or procedure to find factorial of a number, that can be applied to any number without any problem. Such problems are called as deterministic. And till now, whatever you have solved, they all are deterministic problems. There is an another category of problems called as non-deterministic problems. Problems for which there is no systematic algorithm or procedure, they are called as non-deterministic problems. For example, imagine you have a photograph in your hand, right? Someone gave you a photo and you want to find, or maybe I share a image, soft copy of an image, and I ask you to find whether there is a cat in that image or not. So you will write some logic to find whether there exists a cat in that image or not, but that logic may not be applicable for all other images. To make things more clear, let me show you one real-time example, right? Maybe you are aware of Google Images, right? Images.google.com. See here, I am typing cats, right? Now, for example, you can see a lot of cats images here. Now, for example, observe this one. This image I have given, let us assume I have shared this cat image with you, right? Right, this one, the one which is in, gold color, lot of brightness and shining is there. Now imagine this photograph I have given to you, this image file I have given, right? Suppose I have saved this image is shared with you. Imagine this image is given to you and you are supposed to find in this photograph whether there is a cat or not. Now, for example, with a lot of difficulty, you have written logic to find whether there is a cat in this photo or not. But can you apply the same code to check whether there is a cat in this image or not? Do you think it is going to work on this image? Please do respond. So the logic which you have written for that golden color cat, do you think it is going to apply on all other images? Maybe something like this. Is there a cat in this image or not? Yes, there is a cat. But the logic which you have written for the first one, that logic can't be used here to find whether there is a cat in this image or not. So do you agree with me? Do you agree with me? So here is the difficulty. Fine. So the logic once you have written, the logic which you have written to find whether there is a cat in a image or not, that logic will not be applied. That logic can't be applied on other images. So then how many images are there? Just see in Google Images, right? There are more than 10,000 images here, right? You scroll down, you'll get lot of images. So what you will do, will you write 10,000 logics? Is it possible for us to write 10,000 logics? And then you write 10,000 logics, I'll give you some other image which is different from all these 10,000. Then again, I will say your program has failed. So such problems for which you cannot derive a logic, right? For which you can't write an algorithm, fixed algorithm. Such problems are called as non-deterministic problems. And friends, for non-deterministic problems only, we apply machine learning. Machine learning was developed to address non-deterministic problems, right? Forget about cats and dogs. I'll give you one more real-time example where non-deterministic problems are there and machine learning is being applied widely. Please observe here. See the second one, risk mitigation in loans, credit cards, and insurance customers. So, for example, there is an insurance company, and that insurance company has to predict, right, in this year, in this financial year, how many people may claim for insurance, right? You know, what do you mean by claiming an insurance? Suppose I have an health insurance, and if I fall sick or if my family members fall sick, then I will apply and claim for that insurance amount. So if my insurance is, let us say, 5 lakh rupees, and if I have claimed for 3 lakhs, then they have to give me that 3 lakhs, right? Now, imagine for an insurance company, let us say you are running an insurance company and you have 10,000 customers. All 10,000 customers will pay the premium. What is the premium? That every year amount which they have to pay? For example, the premium is 20,000. 10,000 people have paid you 20,000. But out of this 10,000, how many people will fall sick or how many people will claim the insurance? If you can predict, then accordingly you can plan how much amount is required, how much amount you need to arrange, etc. So if you can't predict how many people will claim for insurance, it becomes very difficult. For example, I am your customer and last year I had some health issues and I have claimed some amount out of 5 lakhs. Maybe I have claimed 1 lakh. Now it doesn't mean that since last year I had a health problem and I claimed some amount, it doesn't mean that every time or every year or this year also I will again get the health problem and I claim the amount. It's not like that. So how do I predict what kind of customers will claim or how many customers will claim? I can't tell, right? So for that I can't write a fixed logic. This is one example. Another example, you see spam mails, right? You see spam mails. I'll just show you. I'm showing my email itself. These are spam mails. Spam mails are mails which are generally not important and not relevant to us. Now, See here, I got one spam mail from Institute of Advanced Engineering and Science. I got one spam mail from Sector 6 and another one is related to some student competitions. If you observe, if you observe, all three mails are in spam, right? Means automatically my Gmail has considered them to be spam, and all three are from three different categories. Now, tomorrow I may get some other mail and Gmail will classify it as spam mail. So on what basis you are saying this mail is spam and this particular mail is not spam? Can I conclude like anything related to student competitions is spam? Can I come to a conclusion like that? Can I conclude like that? Yeah, we cannot conclude. That's great. So the reason is, now it's like, non-deterministic problems. If you want to clearly understand, I'll give you an example. There is a football game, right? In football game, there is a goal post, right? So everyone will try to hit the ball in that goal post. If you successfully hit the ball into that goal post by bypassing the goalkeeper, then you will get a point. Now imagine you are playing a football game, and if the goal post is not fixed at a location, goal post itself is changing. At one time it was in the southern part of the ground, sometimes it is in the middle of the ground, sometimes it is in some other place. How you will plan the game if the goal post is not fixed? Is it easy to plan the game? Football players will have lot of strategies and plans, right? How to hit a goal. If the goal post itself is not fixed, how can you plan the strategy? Is it practically possible? Is it possible? Yeah, it's not possible. You can't imagine playing a game like that when the goal post is not fixed. Our non-deterministic problems are also like that. The goal post is not fixed. Goal post is not fixed, because a mail which comes into your spam doesn't mean that all such mails are spam. Tomorrow some new type of mail from any sender will come, even it can be a spam, right? So how do I guess that it is a spam? Previously I might not have seen such email there, but still it is a spam. So how do I come to a conclusion? So here I don't know. I can't give a standard definition or logic or procedure like anything which has got these symptoms is a spam mail. I can't define what is a spam. So based on its irrelevance, based on the interest which the user has not at all shown in that email, how frequently these emails are ignored by user, like that we will try to come to a conclusion like these are not required. And suppose some mails are sent by companies in a bulk form, like 300 mails, 400, then we directly treat them as a spam only, right? So is it clear, friends, what is non-deterministic? Is it clear? Just let me know, is it clear? Yeah. So non-deterministic problems are the problems for which we need solutions. So I can't apply my C, C++ or whatever programming languages we have studied. In those languages, whatever problems we have studied, I can't apply that deterministic problem solving approach here. So I need something else. And before we move on, there is an important observation. Generally, non-deterministic problems are tough for computers to solve, but human brain can easily solve them with their natural intelligence. If you just observe if you recollect that example of cat dog images which we have seen, and we have identified like how difficult it is to write logic for them. But same cat images, Google images, if you show it to a small kid, and ask him to identify whether there is a cat in that image or not. You show him any image, he can easily tell there is a cat here, there is no cat here, there is a dog here, like that. Easily he can tell yes or no. Means for a small kid, it is very easy to identify whether there is a cat in a photo or not, whether there is a dog in a photo or not, and whatever may be the type of the color, type of the cat it is, whatever may be the color, whatever may be the size, a small kid can easily tell yes, there is a cat in this photograph. How is it possible? Because of our common sense or natural intelligence, right? Whereas it becomes very difficult for us to write program to identify a cat in a image or to identify a dog in a image. It is very tough for us. So this is an important observation. Non-deterministic problems are tough for computers to solve because you can't write an algorithm. Whereas all such problems humans can easily solve, right? Now let me define an important word called as artificial intelligence. So since we have observed like non-deterministic problems can be easily solved by humans, right, by applying the natural intelligence, then there is a point. Can we give this natural intelligence to human machines? The natural intelligence which we have, whatever we call it as common sense, can I give this natural intelligence to computers so that computers can also think like humans? The moment when we try to impart this or give this natural intelligence to machines, it is called as artificial intelligence, right? Is it clear, friends? Till this point, is it clear? Please let me know. Till this point, is it clear? Yeah, we'll move on. This is an important diagram, like what is machine learning. So artificial intelligence is not a new word actually. Artificial intelligence is very old word, probably 250 years back this word was used. Means people got the idea of imparting natural intelligence into machines. This idea is not new, it's very old. But AI, but AI became popular. AI became popular only in the last 10-15 years. The reason is the technologies which were applied in the past. Like if you see that Venn diagram, you have something called as a symbolic AI, right? And there was something called as fuzzy logic, search and sorting techniques. Like there are preposition logic. There are a lot of things, there are a lot of things which were applied to implement AI, but AI was not successful, right? Means in the last 15, before 2005, it was not that successful, right? So from 2005, especially after 2005 until date, AI has emerged as one of the prominent technologies, and even you might have heard like everywhere people talk about AI, AI, AI. So today, uh, whatever is the importance of AI and applications of AI in every industry, every organization, it is purely because of machine learning. So let me tell you very clearly the difference between AI and ML. AI means giving the machines the ability to think, giving the machines the ability to think. But thinking is not enough, right? If you can think, it's okay. But after thinking, what you need to do, you have to act on it. You have to do something, right? So that is possible with machine learning. Ability to think is AI, and ability to act on that is ML. And machine learning, evolution of machine learning has made implementation of artificial intelligence very easy. And not only machine learning, today we don't have any scarcity of computing power, right? I'm talking about CPU, right? Computation is not a problem, right? RAM is not a problem, right? How much RAM you want, that much amount of RAM is available because of cloud computing. RAM, processing power, all these things were bottlenecks in the past. Suppose I have a huge amount of data need to be processed, but my computers were not able to do so. But today, evolution of cloud computing, right, and affordability of hardware. Today, hardware is very cheap when compared to hardware in the last 15, 20 years or 30 years back. So availability of data, availability of data. Today, huge amount of data is also available, right? Availability of data, availability of computing power, availability of RAM, all these things, plus evolution of machine learning made artificial intelligence, right, as more popular and easy to implement. So today, success of AI depends on three things. One is the machine learning technology or algorithms, and availability of data, and the third one is availability of computing power. Means you don't have any bottleneck or limitations of like only this much RAM is there, this much computing power is there, like that you don't have any restrictions. So machine learning, right, made implementation of AI very easy. And today whatever is the popularity and success of AI which you are seeing, it is purely because of evolution of ML. Now, inside ML, there are many algorithms. I'll show you various types of algorithms also. But under ML, the subset of ML, there is one more subject called as neural network. So, in machine learning, again, we are going to solve non-deterministic problems, right? So, if I am talking about machine learning, I am talking about non-deterministic problems. Now, in this, again, in the non-deterministic problems also, you have problems of type linearly separable, non-linearly separable. Problems which are linearly separable, they can be solved using machine learning algorithms. What is linearly separable? I will explain you. Don't worry. What is linearly separable? I'll explain. So, in machine learning, again, you have two types of problems: linearly separable, non-linearly separable. Linearly separable problems can be handled with simple machine learning algorithms. Non-linearly separable problems are little complex, and for that we need to apply something called as neural networks, right? Artificial neural networks. And in artificial neural networks also, right, there is one more subset called as deep neural networks, right? This deep neural network is nothing but deep learning. And in deep neural networks, again, there are many types of deep neural networks. In that, one of the popular deep neural network is GAN, GAN, Generative Adversarial Neural Network. This GAN is nothing but our Gen AI. People are talking about Gen AI, right? So Gen AI is generative AI. It is nothing but deep learning only. Again, in deep learning, which is also called as deep neural networks. In deep neural networks, again, you have 7 or 8 different types of neural networks. One type is called as GAN, GAN. That GAN network is nothing but generative AI, right? So till this point, is it clear? This is a very, very important diagram because it gives you the relationship between various subtopics in AI and most important concepts of AI. So till this point, this diagram is clear. Please let me know. Done. Now please observe this. What is machine learning? So in traditional programming, in normal conventional programming, what generally we do, sir, we write a program like addition of two numbers, factorial of a number. You write the logic. Program is nothing but the logic which you have written or the algorithm which you have written, and you give the data. Like factorial of a number program I have written, and I'll give 5 as input, I'll get 120 as output. So this is your normal traditional programming, right? What happens in machine learning is, what happens in machine learning is, you give the output, you give the output, and you also give the data to the machine, and what is generated is the program. Here, this is called as program, but in machine learning, actually you call it as model, right? So if you observe, there is a difference in both diagrams, right? So how different is machine learning from your regular programming? This is the first diagram is your regular programming, and this one is machine learning. In machine learning, what we are doing is we are giving data and output to the machine, and machine will try to generate a program. that program will be used for further applications. Just observe this. The next slide is one small animation. Please try to observe this so that you understand what is ML. This is a very good animation. It was very impressive. So I copied it from intellipath.com. So please observe. First, the man is teaching the machine. Like this is an apple. It says, okay, he's showing another apple. All right. One more apple. Now man disappeared. Something new found. Machine says, stupid human disappeared. Let me guess. So it is repeatedly being played. It's a small animation. So finally, the machine will try to guess that this is also an apple. It's an apple, right? So what it says, if you see these messages, right, the machine finally, when it saw that green apple, it says, stupid human did not show me anything like this. Let me guess. Read this. Look at this object. Stupid human did not tell me anything about this thing. Let me guess. So based on its previous knowledge, it is guessing like this is an apple. Based on its previous knowledge, it is guessing that the new object which it has seen is also an apple. So I can't write a program or logic to find whether a given image is an apple or not. I can't write logic. So what I am doing, I am showing apples to my machine, right? This is an apple, this is an apple, this is an apple, like that. If I need to show cats, I'll show 10,000 different cat images. I'll feed, this is a cat, this is a cat, this is a cat, this is a cat. So what will happen is machine will try to understand various features of a cat. It will try to understand various features, then it will try to derive some pattern. Okay, these many cats I have seen, so generally what are the features of a cat? Now machine is getting some knowledge. That's the reason the subject name is machine learning. Machine is learning. Now, since you have shown me 10,000 different cats, I have seen various features like, okay, every cat will have a tail, the eyes will be like this, the color will be like this, and you have shown me 10,000 images, so I've seen different colors of cat. So I know what are the various features of a cat. Now, once I've seen all 10,000 images, you only told me that this is a cat, this is a cat, this is a cat. So what you are doing, you are giving me output and you are giving me data also. Means you are showing me a cat which is data, and you are telling this is a cat. So cat image you gave and you told it is a cat. So data and output you gave. Like that, how many you gave? You gave me 10,000 images, and for all 10,000 images you said this is a cat, this is a cat. So I'm getting good amount of knowledge. I understand what are the various features of a cat, how many colors cat will be in. Like that, I'll get complete understanding of what a cat is. That understanding, that knowledge, that learning which happened is called as machine learning model or the output. So based on this model, now what I will do, machine learning, machine has learned, right? You have shown me 10,000 images, I got an understanding. Then what will happen? Now you show me a new image. Apart from these 10,000, you show me a new image which was not shown to me previously. And if it is a cat, definitely I can recognize that this is a cat because I know what are the features of a cat. So like that prediction is done. Like that machine learning, that like that machines are given knowledge. So machine learning means machine is learning. How machine will learn? You have to give initially the output and you have to explain. So you have to give the data as well as output to the machine. Machine generates a model or the program. That model we will use for further applications. So this is what is machine learning, and these are the applications of machine learning, right? Machine learning is applied everywhere, sir. This slide shows maximum areas where machine learning is widely applied. It is applied in image and speech recognition applications. It is applied in medical diagnostics, statistical applications, learning associations. And if you see the various types of problems which can be solved using machine learning are classification, You can apply it in classification, you can apply it in prediction, you can apply in extraction and regression, right? These are the various domains or industries where machine learning is widely applied. Manufacturing sector, healthcare sector, insurance, customer service, transportation, e-commerce, automobile. For example, if you take e-commerce applications, all your recommendations which you see in Amazon, Flipkart, right, they are being done based on your buying habits, right? So they see what kind of people are buying what products. Like generally, people in the age group of 25 to 30, what kind of items they buy frequently, right? What boys are buying frequently, what girls are buying frequently, and what a particular person is buying frequently. Suppose I am there, I'll do lot of credit card transactions in Amazon. So what Amazon will do, they are observing me, they are studying my buying habits, they are seeing what items I am buying, what items I am frequently buying, and what is the payment mode I am using. So if I am frequently buying products using credit card, they try to give me a discount in future transactions. Like, you buy this product, we will give you 8% discount on ICICI credit card. So what will happen? I'll be impressed, like, okay, I got 8% discount, so I would like to buy it. So it's like a value added service given to customer and a proper recommendation, right? If I frequently buy mobile phones and mobile accessories, you see lot of recommendations coming in my portal related to mobile phones and mobile accessories. If you are buying lot of clothes, trousers, jeans, etc., you will see lot of offers coming in Amazon on these products. So for each and every individual, we are giving a tailor made customized recommendation, right? How is it possible? It is possible using machine learning, right? Healthcare industry, right? Lot of tumor prediction, right, is done today using ML. And in even agriculture, right, it's missing in this slide. Agriculture is one sector in which machine learning is widely applied. In fact, in our project we are going to work on agriculture domain only, right? So friends, this is brief intro of machine learning. And what uh, specifically we are going to discuss or we are interested in is, please observe this, right? So these are the three major areas where deep learning is applied, sir, right? So detection, prediction, generation, right? So our basic interest is in machine learning, right? So this is about deep learning. Why I'm showing you this slide is, probably now you are working on your mini project, if I'm not wrong. Down the line, if you want to work on any other project in future, you can think of these three areas. Now specifically what we are doing in machine learning is, we are going to go through a couple of papers given by Krishna sir, right? So you need to read that, right? I'll also go through that paper, and what we are finally going to do is, we are going to apply something called as classification, sir, right? One second, right? This is what is we are going to do. Classification is something which we want to apply. So in machine learning, we have algorithms of three types. Machine learning algorithms are of three types. Let me write it here. You are from which year, by the way? You are all final year students. Please let me know. You are from which year? Yeah, you are all final year students. Okay, that's great. Did you study machine learning in 3-2? Okay, no problem, no problem. You are good at Python, or you need any help in learning Python also? You need any help in learning Python? Because we are going to implement our project in Python. So you can unmute and talk. Anyone? Okay. No issue. Fine. So in machine learning algorithms, there are so many algorithms, but they can be classified into types. Machine learning algorithms can be classified into three types, right? Majorly three types: supervised learning, unsupervised machine learning, and reinforcement learning. Reinforcement. So what do you mean by supervised? And again, in each category, lot of algorithms will come, sir. So in supervised learning, we are going to apply supervised learning in our project. Supervised machine learning algorithms. Supervised machine learning is one category. In that, we are going to apply various algorithms. So what is supervised learning means? Basically, it is applied for classification, right? And unsupervised learning is also called as clustering. So let me tell you with a simple example what is classification and clustering. Classification, supervised learning is for classification, and unsupervised learning is also called as clustering. So let me explain you what is classification and clustering. Classification means, for example, for example, in your class, let us say I came to your class and I may ask you a question like, people who are all staying in college hostel, please come to uh, left side, please come to one side, and people who are not staying in the hostel, please stand in the other side. So how many groups I am going to get, sir? My question is, I came to your class and I am saying, those who stay in college hostel, come to my left, and those who stay outside, please come to my right. So two groups I'll get. Can I call them as hostlers and day scholars? Can I use the word hostlers and day scholars? Yes. So before, and imagine in my class there are some 60 students. So I don't know how many hostlers, how many day scholars will I get. But one thing I know, there are only two possible groups and the group names are hostlers and day scholars. So hostler and day scholar, we call it as label. That group name is called as label. So what happens in a classification problem is, I already know that number of groups which I am going to get are 2. In this case, it is 2. So in supervised learning, what will happen, or in classification, what happens is, so what is classification? Class labels are known in advance. Means before I come to your class and before I divide you into groups, I know that I'll get two groups. Yes, I don't know how many people come under hostel category, how many people come under day scholar, that I don't know, but how many groups I'll get, I know very well. I know very well. And what are the labels of that two classes? Here classes is nothing but the groups. Hostler is one class, and what is the name of another class? Day scholar. So వీటిని class labels అంటామండి. So I know class labels in advance. Means I know how many groups I am going to get before actually classifying. So this is called as classification, and we are going to apply classification only on our project, in our project, sorry. Clustering. Clustering means class labels are not known in advance and class labels need not be fixed. I'll explain you with an example. So when I come to your class and ask, boss, how many students are there who are hostlers and how many students are there who are not hostlers or day scholars, straight away I know that only two groups I'll get. Now, what is clustering? It is also grouping, sir. But what is the difference? Let me give you another example. Suppose, suppose I bought, I bought vegetables. I bought vegetables in a bag. Right? I went to market and I bought vegetables in a bag, and I wanted my son to categorize all these vegetables. I imagine I gave a task to my son. I said, please organize, please group the things, separate them, and put them in the refrigerator. So what my son has done, right? He is just 4 year old. So what he will do, sir? Now when I gave the bag to him, can I guess how many different groups I am going to get? Imagine all types of vegetables are there in my bag along with fruits and vegetables I bought. Now, and my son is just 4 year old. Now imagine if I give this bag to my 4 year old son and I say, uh, please to group them together, put them out and arrange them. So what my son will do? How many groups I may expect? So what a 4 year old or a small kid will do, sir? Anything which is, red in color and round in shape, he may think it is one group. Means my son may put tomatoes and pomegranates together. It may happen, right? Because he's a small kid. And bananas as one category, brinjals as one category, right? And potatoes he will separate. Like that, how many groups I'll get? I don't know. I don't know. I can't guess. So if I gave this bag of vegetables to my 4 year old son, how many groups I got? Means, let us say I got 6 or 7 groups. Bananas is one group, potato, right? Then brinjal, right? Lady's finger. Now what my son has done is he kept tomatoes and pomegranates together. He thought they are same. So imagine I got 7 groups. Now when I give the same bag of vegetables, I give same bag of vegetables to my wife. So what will happen? She will make it 8 groups because she knows tomatoes and pomegranates are not same. So tomatoes are separated into one category, pomegranate is separated into another category. And imagine my son has kept all green vegetables in one section, assuming that all are same. But my wife knows very well all green vegetables are not same. Everything which is in green need not be a green vegetable. So what she will do, she will categorize curry leaf, she will categorize all those green vegetables and she will separate them properly. Means if the same bag of vegetables if I give to my wife, I may get 12 or 13 groups. When I gave it to my son, I got 8 groups. So how many groups I'll get? I can't tell in advance. Like that, if I give you a data set of my students, all my final year students, and I'll say based on their performance, based on their academic performance, based on their all other details given to you, please try to categorize them. Then how many categories I am going to get? I don't know how many categories you are going to get. You will not know till you actually solve this problem. One of you may come up with a result saying that, sir, I have categorized your students into 3 groups. All students who have got a placement till now, that is one group, and all students uh, who are eligible but they did not get placement is one group. And you can say all students who have backlogs, that is one group. Sir, I have divided your students into 3 groups. Same final year students data if I gave to you people, you like there are 3 or 4 students in this class now. Everyone will come with a different result. Like uh, Mr. What is that? Anuradha is there. Anuradha, Nishita is there. Nishita may say, sir, I categorized your students into 3 groups, right? Like placed, those who got placed, those who are eligible but not placed, and those who are not eligible. Now Vinutna may say, no, no, sir, I categorized your students into 7 groups. One group is people who are not eligible for placements, people who are eligible but not placed, and people who got placed. In that again I have categories, sir. People who got placed with a double digit package like 10 lakhs and above, people who got placed between 6 to 10 lakhs, people who got placement between 3 to 6 lakhs. And I also identified, categorized your placed students into two more groups: students who got placement in service based companies, students who got placement in product based companies. Means if you want to know how many students got placement in a product based company, I have that information. How many students got placed in service based company, I have that information. And how many students are mm, getting above 10 lakh package, I have that information. So same set of data I gave to Vinutna, she came up with 8 groups. Same set of data I gave to Nishita, she came up with only 3 groups. And maybe some other student, like maybe someone else, Nagaraju is there. Suppose he may come up with a different category. Sir, I have total 10 groups, sir. In that, apart from those which we have listed now, he may add few more things like how many girl students got placed, how many boys student got placed, and in the unplaced category also means students who are eligible but not yet placed. In that, how many girls are there, how many boys are there, and students who are not eligible, in that how much percentage of girls and boys are there, like that. Like, and even in a not eligible category he might have done further division like, sir, students who are not eligible, in that we have 90% of the students with single backlog, sir. Means if these students can clear that one subject, they can also come into this eligible category. Like that, if I give you one set of data, you may divide them into different groups based on different parameters, right? Such problem is called as clustering. Such application is called as clustering. So for a given data set, how many clusters I'll get, can I tell, sir? I don't know how many clusters Nagaraju will give, how many clusters Vinutna will give, how many clusters the other student will give for the same data. But whereas in classification, whoever does the classification, I know very well in advance how many groups I am going to get, right? Because that I have decided in advance. So that is the difference between classification and clustering. Is it clear, sir? Please let me know. Yeah. So, did you notice in Gmail these days, when you type something, compose a mail, when you are typing something, Gmail will give you some advice, right? It is giving you some hint. The next word it will try to predict. Did you notice that any time? Suppose you are typing a leave letter, you want to type a mail to your head saying that, sir, I am not well, and tomorrow, the moment you type tomorrow, because you said you are not well, Gmail will try to give you some input. Tomorrow I need leave, like that. Whenever you type something, the next words are being suggested by Gmail. Did you notice that? Did anybody notice it? And one more thing, yeah, and one more thing, when you get an email, previously, some 2 3 years back, we never used to get any buttons. But these days, whenever you get an email, see here, uh, I'll show you one live. You might have seen uh, in some mails, you will get some 2 or 3 buttons saying that what you need to reply. That like, yes, I have received your email, thank you for your email, yes, I acknowledge your mail. Like that, you will get some buttons, 2 or 3 buttons automatically. Have you ever seen that? Let me show you some mail. Mm, you might have seen here, instead of reply, you can see some messages like thanks for your email. Like that, in some mails you will get an auto reply kind of thing, which you click, that reply will go, you need not type anything. So all these things which you are seeing in Gmail, it is because of reinforcement learning, sir. The third category, reinforcement learning means Machines will learn by their experience. Machines will learn by their feedback, by their mistakes, right? For example, in Gmail, when you type something, you are getting some help, right? Now, previously, 2 3 years back when this was started, the suggestion which we used to get from Gmail was most of the time it was inaccurate, inappropriate. So we never used to take those suggestions. But after 2 years, today it has improved a lot. So precisely it is giving the next word means mostly I'll take the next word from Gmail instead of typing. So that improvement is possible because of reinforcement learning. So like that you have varieties of ML algorithms, categories in fact. So supervised, unsupervised and reinforcement learning. In that supervised learning is nothing but classification, and we are going to work on classification only. So in classification or supervised ML algorithms, we will see how many algorithms are there in supervised ML, and we'll try to understand them. Then we will try to apply those algorithms on our base paper, which was given by Venkatakrishna sir, right? And before we wind up, we'll wind up in another 1.5 minutes. Before we wind up, I'll just show you something which maybe you are aware of it, right? In Google, you have something called as Google Colab. Google Colab. This is a cloud platform of Google called as Google Collaboratory, right? To access this Google Colab, you need to have just a Gmail account, sir. That is enough, right? So this is a place where you can type your Python programs, and since it is a cloud, no, it will be saved. So you need not carry your laptop or desktop. Wherever you go, you can continue your Python programming, and they are stored in cloud, so there is no question of losing your code also. See here, I have a Gmail account. You might have a Gmail account. So simply you type, recent, see, new notebook. So it's an online platform where you can, with Gmail, you can log in and you can create a notebook and type your programs, right? So give a name untitled 8 dot Python notebook. PYNV means Python notebook. So give a name to this one. You can rename it, give some name. Now start coding here. So you can type here something like this. X is equal to 10, Y is equal to 20, print of x plus y. Let me run this. So you can see here it is saying connecting. It will connect to that Google Cloud and it will give you RAM space, it will give you CPU, everything. See here. I got 1 GB, 12.67 GB of RAM is given. I am not running Python program in my computer, sir. And I got a hard disk space of 107 GB. And it has given me a Python 3 editor. See here, addition is done. This is a place where you can type your programs and automatically they are present forever in this Python notebook. Just give a name to it. Something like this, practice. Fine. See here where it is getting saved. It is getting saved in your Google Drive. So it will be permanently available. So create a Google Colab notebook and practice Python programming in Google Colab notebook. And in order to, since you said you are intermediate stage in Python, you please practice Python. What I'll do is I'll give you two PDFs in which you have all Python basics covered. So go through that PDF and type. There are code snippets also available. Please type them in Google Colab. It will become a practice for you. And once you are little comfortable in Python, maybe after 3 4 days, we will slowly start understanding machine learning algorithms. Okay. So make a habit of using Google Colab. So after this class, I would like to share. I'll share that Python material so that you can start practicing. Python is a very easy language. Don't worry about Python. My material which I'll give will be more than enough to understand and practice basics of Python. Okay. Yeah, Google Colab is exclusively for Python only. Fine. Any doubts? If you have any doubts, please let me know, or else we will wind up the class. And if possible, I'll share this recording also. So you are able to follow me, sir? Is the subject clear? Give your feedback or input so that next time, if required, I'll make some changes also. You are able to follow me, right? Everyone, please let me know. You are comfortable with me or not? Yeah, you can extend the RAM and storage if necessary. What happens is, for the programs which you are running, the amount of 12 GB RAM which you are getting is more than enough. But suppose if you are working on some real data sets, and if your data set is 4 GB, 5 GB data set is itself is 4 5 GB, then you can extend. See, it is cloud, right? So there is no upper limit. You can extend to any amount of RAM and processing power also. But under your free account, you will not be able to get more than 15 or 16 GB, right? So suppose if you really want to work on 4 GB, 5 GB file, then your Google Colab will ask you to go for a premier version. Means you have to pay for that. Okay. But for our project, Aditya, it will be more than enough. Okay, then thank you everyone. We will wind up the meeting. I'll stop the recording. I'll try to share this video link also. Thank you.